Hi, thanks for stopping by. I know it's been a long time, but let me start with a very easy topic today, Java records. So, if you have been programming in Java for a while now, you would definitely know about Java records, which lets us define plain data aggregates with less ceremony than normal classes. So, what exactly are these terms? Data aggregates and less ceremony. What does it mean? So, data aggregates are nothing but plain old Java objects that you would have created in scenarios where you wanted to just take some data and move around between your web layer and service layer, or web layer to the UI layer and things like that. So those are the so-called value objects or data transfer objects that just had some fields and getters and setters to modify them or access them. So to create such classes, it used to be a ceremony in Java, right? You had to follow the Java bean pattern. You need to have getter setters. You might have to have constructors based on how you are creating it. You will need equals and hash code and things like that to define the class properly, right? So Java records enables a very easy way to define such data transfer objects called state description. So using state description that Java records provides you, you can define such data aggregates without any ceremony. And once again, these data aggregates or records rather are supposed to carry some data and not have any kind of behavior. So now let's take a look at how do we define records. So as I said, records are defined using state description. So let's create a new record, and a good example would be employee. I'm saying my employee value objects or data transfer object needs an ID, let's say long ID, and string first name and string last name. So that's it. So this is all you need to define when you're defining a record. Nothing more is required. So this is definitely a very big improvement on how things were done in the Java world. Now also look at this new keyword record that is introduced, just like enum was introduced at some point. And you generally use public class or public interface. So similarly, there is public record. And also this record has become an official part of Java since Java Standard Edition version 16. Now let's take a look at how do I use this employee. Now, not to confuse you, right? I mean, this is just like any other class. So let's take a look at what is the build output of this this record, right? So let's just try to build this. Let's say build. So once the build is done, let's take a look at the out folder. There is an employee class generated. Now let's go to the folder through the command line. Okay, so my records, open in terminal, and let's see there is an employee.class generated based on this record. Now let's see what are the things that Java has generated for us. Here is the output. So this record has been created as a class which extends a base class called record. And once again, here are the fields I want, right? I said I need long ID, I need first name, I need last name. And then by default, it has created an all argument constructor based on this description. And then I have toString function generated by Java. I have hash code, I have equals, then a bunch of getters. So this is exactly how a value object should behave. Basically immutability, right? Once you create it using the constructor, you don't have any ways to change the fields using setters. So only that you have are the getter APIs. And one more thing that you would like to notice at this point is that these new getter methods are not generated with the get prefix like the good old Java bean rules used to be, right? I mean, here you don't need the get. It's just once you say employee.id, you will get the ID as a return value. So that's all about it. So now let's look at let's write some test just to see how this all looks. So let's say a tester class, and let me define a main where I'm going to create employee e1 equal to new employee, and I'm going to provide an ID and a first name and a last name. So that's it. So my employee is ready. Now let's just see what happens if I just print it, right? So if I print it, the newly generated toString will be called, and I get a nicely defined toString output from this class. So now somebody might say, why would I have all these things printed? I mean, maybe this is like secret protected information. I don't want to print it. Nothing stops you from going here and overriding any of the methods. Let's just say override the toString method. You can just override and put whatever you want. So let's say string dot format. Let's say let's just say like protected, and I don't want to show anything, right? So you can do things like that. So there's nothing that stops us from overriding what Java is providing us. So okay, that's enough. Actually, I didn't have to really format anything. So now let's run it again. So if I run my code again, I see the overridden toString. So similarly, you can change when required, but up to your use cases, right? So that kind of summarizes what exactly a record does. Now, one thing that we should remember is that record allows you to define, generic types. You don't have to be really sticking with a specific type like the example I did. Also, records, you can define some new constructors if you want. For example, right now, the employee is created only with the default constructor, and I like to always construct employee like this. Now I need to construct the employee. Suppose in some cultures we may not have a last name always available. So in such cases I need a constructor that constructs the employee with just the ID and first name. Let's try that. So what I'm going to do is public employee, and I just need the ID and the first name. So when I define like this, the way we implement this is you have to call the default constructor from here, ID, first name, and let's say we always set to last name unknown or something like unknown, just for our purpose. So that's one way to create your own constructors if needed. So let's say I'm going to create a new employee, and the ID this time is this, and I'm just going to create the first name and no last name in this case. So let's print that e2 and take a look at that. Oh, sorry, still in the protected. So I'm just removing my override. And let's try to run it again. There you go. So my new constructor was called, and last name is default set to unknown in this case. So that's how you would override and provide some additional constructor or toString or something to the records. And also one more thing that we should know is that suppose somehow we want to do some checks in the default generated constructor. How would you do that? So Java has come up with a new syntax once again. It's called it looks very new actually. You have to just say employee, and that's it. So this means the default constructor, not exactly default constructor, I'm sorry, default generated all args constructor. That's what this is. Okay, so I can put some additional checks here. Suppose I always want to say if id is less than 1, I want only ids which are greater than 0 always, right? So I can do a check here, throw new illegal argument exception and say ids should be greater than 1. So you can do some checks like that using this new all args default constructor notation that you can use, and this is pretty new to Java, this kind of notations. So now let's go here and try to create an employee with 1 or 0 as the ID, and let's see what happens. I got the expected error saying ID should be greater than 1. So that's how you would change certain behavior if at all you have to do. So this is how you would use records. And I know a lot of people might say, what is the big deal? This was already available if you had Lombok. And if you haven't used Lombok, I strongly suggest you check it out what it is. It actually provides a lot of very nice annotations to avoid a lot of ceremonies in Java. One particularly that I like is the builder annotation, which lets you create a builder pattern to create your objects. And similar to record, Lombok provides you this value annotation, which is very similar to what record is doing as of today. And then there are a bunch of other annotations like all args, constructor, and you can include and exclude things from your toString, and a lot of things you can do with Lombok. So it's really worth checking out. So let's consider something here. Should you stop using Lombok given that records are there? If you have been using Lombok only for @value annotations, probably you can just get rid of that dependency and depend on the default Java library by using records. That is one choice. But if you are using all the other features from Lombok, like especially the logging @SLF4J or log4j, things like that, that's very beautiful annotation available from Lombok, and you should continue using it. And that's what I would say. And the choice here is obviously the blue pill. Now, let's go ahead and see some properties of records. Like you can use generics, and you can add some initializers if you want. You can have, pretty much everything like static fields, type variables, interfaces. But at the same time, you cannot have a non-static instance variable other than that appears in the straight description. Let's go here and try that. What I said is, suppose these are the fields I have in the state description. Now I want to secretly add an internal field. Let's say private string address. This is not allowed because it is not appearing in the state description, and hence you cannot have a field like that and do anything with it. Okay, so that is the whole idea. So if you are planning to create a record, you should have all the fields right here in the state description. That's it. And one more thing, though the name record indicates like a record in a table, you cannot use records as an entity in Hibernate or JPA and frameworks like that, primarily because records are immutable. And also, the purpose of record is to just represent data that moves around between layers, and not to really represent a record in the database table. And hence, you cannot use that in Hibernate or JPA. So that pretty much brings us to the conclusion of our discussion. But I just want to touch upon a very important point, where the future of records. The future of Java records is not only to represent value objects, also it is to represent a pattern called pattern matching and record deconstruction. This is a very interesting language feature that is going to come up in future versions of Java, where you could do something like an example that I'm going to try to build here. So let's say I'm going to use this tester class for all my purpose. So let's say there is we want to build an expression evaluator. So let's start with an interface expression. Okay, Now records can implement interfaces. So let's start with an expression called record add expression implements expression. And this can take, I'll come back to this, but before that, I'll say record constant expression implements expression. Sorry, the syntax is like this. So here you can see add expression. What you can do is that you need to have, you can have one expression left and another expression right. So add is like you add left and right, both can be expressions, right? That's how you will represent. And now let's say similarly, I have a mult expression. So similarly, you have a left expression and right expression. Yeah. So that pretty much would be, let's say, constant expression of some integer I, right? So these are the things that you can do with expressions. Now let's say we want to define an evaluator that evaluates integer. So let's say public integer int evaluate expression E. So now the beauty of the upcoming feature is pattern matching and record deconstruction. So you can write something like this: return switch of this expression, and you can write some things like this. You can say case constant expression of int I. What do you want to return? You want to return I. Case add expression of expression left comma expression right. You can return L plus R. Sorry, evaluate L plus evaluate R, right? Because we want to still continue evaluating both sides and then add them, right? Similarly, case multiple expression, expression left, expression right, which will return evaluate left multiplied by evaluate right. So this is how you will make use of this pattern matching and record deconstruction. Record deconstruction meaning you should be able to directly use these variables in your expressions after matching these patterns using case. And as you can see, I'm getting an error saying, see, pattern guards and record patterns are not supported in the language that I'm currently using, but in future this is going to come to Java, and at that point of time a lot of different type of expressions we should be able to build in our implementation. When I said expression, it doesn't mean mathematical expression, but what I meant is you should be able to solve certain problems or even improve your code using these type of implementations. That pretty much wraps up the introduction about Java records. I hope it was helpful. I'm going to post more content in coming weeks. Meanwhile, please like, subscribe, and press all kinds of buttons. I don't know, bell button, is that's what it's called, because that will encourage me. Thank you. Bye.